Welcome to Ms. Parb's Flipped Classroom. In today's lesson we're going to be talking about quadratic functions. The objective will be to graph a quadratic function of the form y equals ax squared plus bx plus c. And the standard form of a quadratic function is y equals ax squared plus bx plus c. A is the coefficient of x squared, b is a coefficient of x, and c is a constant and is just a number. Important points on the graph of your quadratic are your vertex, axis of symmetry, y-intercepts, and x-intercepts. And if you look at this graph of this quadratic function, it opens up so your vertex down here is your lowest point or a minimum. Your x-intercepts are where your graph crosses the x-axis. Your y-intercept is here where the graph crosses the y-intercept. And if you notice, from the vertex we went 2 places to the left and up 3. So if we go 2 places to the right and up 3, this would be the point reflected across the axis of symmetry. So here is your y-intercept, and reflected across the axis of symmetry is this point. And your axis of symmetry goes right through the middle of the vertex. To calculate these by hand, you use the a, b, and c from your standard form of the quadratic. The x of the vertex is a negative b over 2a. The y of the vertex is f of negative b over 2a. So that means your vertex would be the point negative b over 2a, f of negative b over 2a. And we'll talk in just a minute about how you calculate that. The axis of symmetry, since it goes through the vertex, is always x equals the x of the vertex. Your y-intercept, when your equation is in standard form, is always the point 0, c. So let's look at an example. We want to graph the function y equals x squared minus 6x plus 4. So our a is 1 because there's nothing in front of the x squared, so it's understood to be 1. The coefficient of x is a negative 6, so b is negative 6, and our constant is a positive 4, so c is 4. Okay, the steps that you want to follow anytime you're trying to graph a quadratic function is to first identify a, b, and c. Then you want to find the x and y of your vertex, your y-intercept, and then use those points to graph the function. So we already said that the a, b, and c were these points. The x of the vertex is a negative b over 2a, so we substitute in the opposite of negative 6 divided by 2 times 1, which gives us 3. And then the vertex is y of this, f of this, which means we want to do f of 3, which simply means we go back to the original equation, and any place we see an x, we replace it with a 3. So we had x squared, so we replace that with 3 minus 6 times x, so we replace that x with a 3 plus 4. You can either work this out by hand or substitute it into your calculator just like you see it, and you will get y equals negative 5. So your vertex is the point 3 from here and negative 5 from here. Your axis of symmetry is going to go through the vertex, so it is x equals 3. Your y-intercept is the point 0, c, which would be 0, 4. So we graph the vertex, 3, negative 5. We draw the axis of symmetry right through the vertex. Our y-intercept was 0, 4, so we graph that. We reflect that point across the axis of symmetry to give us a point over here, and then we just draw the parabolic curve through the points. Okay, so for the got it, you want to try to graph the function y equals a negative x squared plus 4x minus 2. And I put some hints on here to help get you started. First of all, find the vertex and graph it. Find the axis of symmetry and graph it. Find the y-intercept and graph it. And then find one more point, possibly this point reflected across the axis of symmetry. So go ahead and copy this down. Pause the recording and work it out. And then start it again to check your answer. Okay, the vertex is going to be a negative b over 2a. So that will be the opposite of 4 over a negative, or 2 times a negative 1, which will give us a negative 4 divided by a negative 2, which will give us a 2. So we know the x of the vertex is 2, We also know already that the axis of symmetry is x equals 2, and now we need to find the y of our vertex, which is simply the function of this 2 that we already found. So we're going to replace the x's up here with 2, so we have the opposite of 2 squared plus 4 times 2 minus 2. So 2 squared is 4. The opposite of 4 would be a negative 4. Plus 8 would be a positive 4. Minus 2 would be a positive 2. So we know the vertex is the point 2, 2. So we can graph our vertex. We can go ahead and graph the axis of symmetry. Our y-intercept will be the point 0, and c is a negative 2. Be careful, remember that negative sign goes with that 2. So our y-intercept is a point 0, negative 2. We went 2 places to the left and 2 down, so we go 2 places to the right and 2 down, and there is our reflected point. And now if we draw our parabola, we notice that it opens down instead of up, which is exactly what we would expect because a is a negative 1. And remember, anytime a is negative, your parabola opens down and your vertex is a maximum. Okay, let's talk about some word problems that they might give you using a quadratic function. Notice that if you have somebody throw a ball, it goes up and then it comes back down. Notice that shape is just like what we've been graphing. It's a parabola with a negative a because it opens down. And our vertex would be a maximum. So anytime that you want to throw, shoot, or launch an object into the air, you should be thinking about a quadratic function that gives you this shape. The vertex will tell you the maximum height, so if you want to know how high did they throw the ball, you would find the y of the vertex. If you want to know how far the ball traveled, you would go from the x-intercept here to the x-intercept here. That would give you the distance that the ball traveled. Or you could graph it versus time, and then when you went from the x-intercept to the x-intercept, it would tell you how long the ball was in the air. So the quadratic function is really useful in these kind of situations. And what you use this for, the x-intercept, depends on what you're graphing. If you're doing height versus time, then this would be time in the air. If you're doing height versus distance, then that would be the distance that it travels. You can find all of this information manually by working the problem just like we did in the slide before, or you can use the y equals key on your calculator, plug in the standard form of the equation, and let the calculator graph the function for you, and then you can use the trace, the calculate, or the table feature to find this information.